We are covering pipe flow for the FE civil exam, specifically how to calculate and differentiate between major and minor head losses. Head loss represents the energy lost due to friction and other disturbances in a pipe system. Major losses are due to friction along the entire length of a pipe, while minor losses occur at specific points like bends, valves, or changes in diameter. For major losses, you have two primary equations in the NCEES reference handbook. The first is the Darcy-Weisbach equation, H sub F equals F times the quantity L over D times V squared over 2G. This equation is your universal tool. It works for any fluid under any flow condition, whether laminar or turbulent. The most complex part is finding the friction factor, F. To do this, you must first calculate the Reynolds number to determine the flow regime. If the flow is laminar, typically a Reynolds number less than 2300, you'll use the simple formula F equals 64 divided by the Reynolds number. If it's turbulent, you must use the Moody Diagram, found in the handbook, which requires the Reynolds number and the pipe's relative roughness. A huge exam trap is misreading the logarithmic scales on the Moody Diagram or using the laminar formula for turbulent flow. Always check the Reynolds number first. Your second tool for major losses is the Hazen-Williams equation. This is an empirical formula, and a critical point for the exam is that it is only accurate for water at ordinary temperatures. The exam will try to trick you by presenting a problem with oil or another fluid. In that case, you must use Darcy-Weisbach. The Hazen-Williams equation uses a roughness coefficient, C, with typical values ranging from 100 for older pipes to 150 for new smooth plastic pipes. Pay close attention to the units, as the handbook provides specific forms of the equation for SI and USCS units that must be followed exactly. Now, let's discuss minor losses. These are caused by components that disrupt smooth flow, such as elbows, T's, valves, and sudden pipe expansions or contractions. The formula for minor loss is H sub m equals K times V squared over 2G. K is the dimensionless loss coefficient, which you will find in tables within the NCEES handbook for various fittings. For example, a fully open gate valve has a very low K value, while a 90-degree threaded elbow has a much higher one. A typical FE civil problem will require you to calculate the total head loss for a system. This is simply the sum of the major loss and all the individual minor losses. You'll calculate the major friction loss over the total pipe length using Darcy-Weisbach or Hazen-Williams. Then add the minor losses for each fitting by finding its K value and applying the minor loss formula. For instance, a system with 100 meters of pipe, 2 elbows, and 1 valve would have a total head loss calculated as H sub F for the pipe plus 3 separate H sub M calculations, 1 for each component. Here's a mental shortcut to keep this straight. Major is for the miles, minor is for the manifolds. This helps you remember that major losses are calculated over the long run of the pipe, the miles, while minor losses are for the collection of components like valves and bends you'd find in a manifold. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.